given assembly level program to get the data from a PC and display it to port 1. Okay. So we are getting it from PC and displaying it to port 1. Assume that 8051 is connected to the PC and observe the incoming characters. So we are going to get the characters, and as you press any key, the ASCII value of that character will be transmitted and it will be displayed in the LEDs. So you will be getting the ASCII value. So data to ASCII value conversion. So the program is ORG000, the origin we are starting. So move tmod as 20H, it is nothing but we are going to configure timer 1 in auto reload mode. So this is for baud rate calculation. -6 is the baud rate we are going to fix, and it has been loaded as a count value TH1. TL1 will be automatically reloaded, and each time it will be done. And then SCON 50H is nothing but 8-bit character you are going to transmit with one start bit and one stop bit. Okay, so 10-bit character is going to be transmitted. So we are configuring the serial configuration register as 50H. Then we are starting the timer. So the need of timer is to have the baud rate. After that, we are going to check for the receive interrupt. If the receive interrupt is occurred, the data what is to be observed is been loaded into SBUF. So if it is loaded into SBUF, only accumulator can access it. We are using this instruction and transferring the SBUF content to the accumulator. And from the accumulator, we are transferring to the port 1. Okay, parallelly we are transferring to port 1, and we are clearing the RI. So what is the need of clearing the RI? So each time, whenever we are getting the data, we have to clear it, or the next data will not be taken. So whatever previously data observed, it will be taken as it. So in order to avoid that, we are clearing RI, and each time the fresh data has been taken from the SBUF and it has been loaded. So if you fail to do this step, automatically this will be enabled, and whatever previous data is there, it will be taken. The garbage values will be taken. So in order to avoid that, we are having clear RI. And this operation has to be repeated simultaneously and end. So this is a program for ending. Okay. So now yes, we have created this program. We are going to add this program already added. We are going to create the X file. So already the options we have done. The same name we are going to create the X file, and then we are building it. So X file has been created. So now we can observe the output in the debug window. Okay. So you are having this input window, you want one, and the output window we are going to observe in the port. Okay. So I hope everyone have the textbook. You please refer the X values, ASCII values, X values. So let us take the first data. Run the program. Okay. And in the UART window, we are going to press the character. So 0. Let us assume 0 is the equivalent value in ASCII hexadecimal format is 30. Okay, we can observe it. Small a if you give 61. Okay, caps A if you give 41. So if you observe that in your table, you can find the output. So this way you can print screen the outputs. This is with respect to the simulator. Now the same thing we can observe in the hardware. Okay. So the procedure for that is already X file has been created. We are using here the same name we are used because we have recreated the same X file for the new program. Okay. So we are going to here flash magic. No problem. So we are going to flash magic. We are going to give a browser. We are going to have that file VAT. Okay. So start. We are dumping it. Okay. After resetting, the file has been dumped. Again reset. Now it is in the run mode. Okay. To observe the output, we have to go for the terminal. We are opening the terminal. Okay. COM3 port, because we have configured to COM3. The baud rate we are going to fix. So 4800. We have to configure that as per the data what we have loaded. Okay, in the program. Okay. Then we can observe that window. Now in this window we are going to give the input, and this output we are going to observe in the parallel port. So for parallel port we are going to take as output port. The LEDs has to be connected to the appropriate port. Okay, we are connecting to the port 1. Now we can observe the outputs as per the character loaded. So let us assume the first input we are going to give 1. 0. Okay, we are going to observe for 0. So you can observe the equivalent ASCII value as a LED glowing. Okay, 30, 30 you will be observed. Okay, so 0011 is 3 and the remaining 00, so 30 H.
Now caps A.
Okay, now caps A we are going to give. So input is caps A. So output you can see that. So equivalent is 61. Correct? Small a. We will be observing 41 will be getting. Okay. So this is the procedure for observing the output in the hardware as well as in the software. So these two programs you are going to do. Okay, as for the hardware models. And remaining task you are going to just do in the software. No need to do in the hardware. So whatever the task is given to you, it has to be done in the software. So whatever we have demonstrated, it has to be done in the hardware. So you can observe the outputs in hardware and take the photo of the hardware. Thank you.